Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss the assembly language instructions. So in this lecture, we are going to discuss the contents, the classification of assembly language instructions. Then we will discuss the instruction formats. So we have different instruction formats like 0 operand instruction, 1 operand instruction, 2 operand and 3 operand. So these are the different instruction formats. So all those we can discuss in the instruction formats. So let's start with the instruction types. So instruction is a command to the processor to perform a operation or to perform a function. So that is called instruction. So all these different types of instructions we are grouping together based on the operation. So based on the operation, the instructions are grouped. So these are called instruction set. Okay. So these instruction assembly language instructions are classified into mainly three types. First one is the data transfer instructions. So this is the first one. Second one, data operation instructions. And the third one, program control instructions. So these are the three main classification of the instruction set. Okay. So let's see one by one. So first one is a data transfer instructions. So that means, as the name it describes, data transfer. That means using this type of instructions, we can transfer the data from one place to the another place. So that is the use of this data transfer. So when we are copying the data from one place to the another place, just we are copying the data. So suppose if you have a move A comma B. So this is a one assembly language instruction. So data transfer instruction. So that means here A and B are the two 8-bit registers. Let us assume 8-bit register. So here we are transferring the data from register B to the register A. So that means when we are copying here, we are only doing the copying the data. Okay, we are not doing any manipulation. Okay, so here only the contents of the B register we are copying to the A register. Suppose if the B register contains some 4-5 data, then that 4-5 data will be copied to the register A. Okay, so that means here the contents of the B register is retained. That means it is the same. It will not. We are not modifying the source operand. So B is called source register, and A register is called destination register. So that means here the data present in the source register we are not manipulating or we are not modifying. Only we are doing the copying the data from one register to the another register. So the instructions which are used to copy the data from one register to the another register are called data transfer instructions. Okay, so these are the data transfer instructions. So using this data transfer instructions, we can copy the data from one place to the another place. So here we will see what are the different data transfer ways. So first one is load the data from memory into the microprocessor. So if you look into the basic computer organization, so mainly it is having some CPU, so CPU, memory unit, and input output units. So it contains mainly three subsystems: CPU, memory subsystem, input output subsystem. So these are the three. So that means here we are copying the data from one subsystem to the another subsystem, or one component to the another component. So first one is load the data from the memory into the microprocessor register. So that means, so in general, we will store the data in the memory. So that data we are copying to the registers which are available inside the microprocessor. So microprocessor, so inside the CPU we have many registers. So we can copy the data from the memory to the registers of the microprocessor. So that is a first way of transferring the data. So that means load the data from the memory to the registers of a microprocessor. And coming to the second one is store the data from the microprocessor into the memory. So that means opposite operation of to the previous one. So that means the microprocessor. So microprocessor is available in the inside the CPU. So CPU acts as a microprocessor acts as a CPU. That means the microprocessor, it contains multiple registers. So the data available in that registers we are copying to the memory. So that is another type of the data transfer. And third one is move data within microprocessor. So that means already we have seen the microprocessor, it contains multiple registers. That means we can copy the data from one register to the another register available inside the microprocessor. So register to register transfer. So these are the three. And next, input data to the microprocessor. So already we know the functioning of the computer. So computer will accept the data from the outside world using the input device. So from the input device, the computer will take the input, then it will process. So after processing, it will generate the results, and the generated results will be given to the user through the output devices. Okay, so that means in order to accept the data from the input device, okay, so we are using a input devices. Okay, so input data to the microprocessor. That means the data which is coming from the input device will be given to the microprocessor. That means transferring the data from input device to the microprocessor. Okay, so the microprocessor may need to obtain the data from an external device. Okay, that means we have different input devices are there, like a keyboard, a mouse, joystick. So these are all the different input devices. So the computer can accept the data from any of these input devices. So suppose, for example, if you consider a microwave oven controller, microwave oven controller. So the microprocessor must know which key was pressed. That means in a microwave controller, so there is a keypad given. So that means there is a switches given to interact with the microwave oven, because the microwave oven, it can be used to heat the food. So what type of dish we are going to heat, what it should be cooked at what temperature. So like that, we should interact with the microwave oven. So for that purpose, the keyboard is given. Okay, so the microprocessor which is inside the microwave oven should know which key was pressed. Okay. Okay, so the microprocessor, it inputs the data from the input device, the keyboard in this case, into one of its registers. Okay, so that means the data coming from the input device will be transferred to the one of the registers inside the microprocessor. So that is another way of the data transfer. And the last one is the output data from the microprocessor. So already we have seen. So once the computer, it process the input data, then it generate the results. So that generate results will be given to the user through the output device. So that means the data which is present in the registers of the microprocessor will be given to the output device. So that is another way of transfer. So these are all the different possibilities of the data transfer inside the computer. So first one is the data from the memory unit to the registers of the microprocessor, and the second one is the data. This data transfer instructions can copy the data from the registers of the microprocessor to the memory, and third one is the data transfer within the microprocessor. That means register to register. So within the microprocessor. So that means register to register, register to register transfer. And the fourth one is we can transfer the data from input to device to the one of the registers of the microprocessor. And the last one is one of the register to the output to device. Okay, so these are all the different data transfer. So this data transfer instructions can be used to transfer the data from this one place to the another place. And coming to the second type of classification, that is a data operation instructions. So unlike the data transfer instructions, so the data transfer instructions we are using only to copy the data from one location, from one place to the another place. But the data operation instructions are not like the data transfer instructions, because in the data operation instructions, so the instructions will modify the content, will modify the data present in the register. Okay, so that is the main difference between the data transfer and data operation instructions. So the data transfer instructions will not modify the register's data, but the data operation instructions will modify the register's data. So this data operation instructions, they will operate on one or two data values. Okay, one or two data values. That means in order to perform the data operations, so sometimes it requires only one operand, but sometimes it requires more than one. That means two operands are required. Suppose if you want to perform the add operation, like add a comma b. So this is one of the assembly language instruction in order to perform the addition. So here we have two registers here, A and B. So that means here the contents of this B register will be added with the contents of the A register. Okay, so that means here in order to perform the addition operation, we require two values. Two values are two operands. Operand is nothing but the data on which we are performing the operation. So one value will be stored in the register B, and another value will be stored in the register A. Okay, so for this particular operation, it requires two operands. Suppose if you want, if you take any other operation, CLA, that means a complementer, clear accumulator, CMP. Okay, so this is a compare A comma B, and if you want to take, if you take a complementer accumulator, so complementer, so that means generally we are performing this complement operation on only one type of data. Okay, one type of data. That means suppose if you give a register A, so in register A we have some data. So the whatever the data is present in the register A, that will be complemented after executing the complement instruction. Okay, so that means here we are using only one operand. So based on the operation, it will take either one operand or two operands. Okay, so these data transfer instructions are classified into three types. First one is arithmetic instructions. So in arithmetic instruction, we have different arithmetic instructions like addition, subtraction, multiplication, division, increment, decrement, and clear. So these are all the different arithmetic instructions. Similarly, the logic instructions. So logic instructions are and, or, XOR, and complement. Okay. So logical and logical or, logical XOR, and complement. So these are all the logical instructions. And coming to the shift instructions. So shift instructions are used to shift the data present in the register. So that means the data present in the register we can shift either left side or right side. Okay. So these shift instructions are classified into again three types, that are logical shift instructions, arithmetic shift instructions, circular shift instructions. So this is a main classification of the data operation instructions. So if you take a addition arithmetic instructions, so these are all the different instructions: addition, subtraction, multiplication, division, increment, decrement, and clear. So suppose if you take a addition operation, then it will add like this: add a comma b. So that means the way b register, it is having some value 04. Similarly, the register A, it is having some 05. So that means the contents of the B register, that means the 04 value will be added with the A register. So after adding, finally the result automatically will be stored in the accumulator A register. So once we have added added the contents of the 4 plus 5, then the result will be 9. So the register A, it will be the 5 will be replaced with the 9 after the add operation is performed. Okay. Similarly, it performs subtraction, multiplication, division, increment, decrement. So increment, decrement. That means so whenever the increment instruction is executed, the contents of the register will be incremented by 1. So suppose if you take example increment A. So that means we are incrementing the value of A register. Suppose if the A register it contains, so if you consider a 8-bit register, if you consider a register A, then it is having some value. So like so this is equal to 0, 5. So that means the register A, it having the value 0, 5. So once the increment operation is performed, then its value will be incremented by 1. So that means after performing increment operation, the register A, it contains value 6. That means we are incrementing. That means 5 plus 1, 6. Similarly, decrement. So decrement, it can be used to decrement the value by 1. Suppose if the A register having a value 5, then it will be decremented by 1. That means 5 minus 1, 4. So finally, the 4 will be stored in the register A. Okay. Next, clear. Clear. The clear means it can be used to erase the data present in the register. Okay. Suppose if the register having some data, then after executing this clear instruction, the content of the register will become all zeros. That means cleared. Okay. So these are the different arithmetic instructions. And coming to the logic instructions. So these logic instructions are AND, logical AND, logical OR, logical XOR, and complement. Okay, so these logic instructions are performed on bit by bit. So bit by bit. So suppose if you consider a AND operation and A comma B. So let us assume the B register is having some 0, 8. On the A register it is having some 30. So we are performing the AND operation between the contents of the B register and A register. So let's see how we can perform the AND operation. So the register, we have two registers A and B. So A register is a 13. So in BCD form we can write 0 0 0 1 and 3 is the 0 0 1 1. Similarly the B register it holds the value 0 8. So 0 0 0 0 8 means 1 0 0. So now we are performing the AND operation between every bits. So we are performing the AND operation between the 1 0. So before doing the AND operation, we should know the AND operation. AND operation is a if any suppose if you have any two inputs, okay. So 0 0 0 1 1 0 1 1. So this is the output. Okay. So if any one of the input is logic 0, then output will be logic 0. So output will be 1 only if all the inputs are logic 1s. So this is a truth table of the AND operation, AND gate. So 1 0. We are performing the AND operation between this 1 and 0. So it results 0. So next we are performing on the second bit. So 1 0 0. So 0 0. We are performing the AND operation between the two zeros. So it results 0. Next 0 0. So here that means after performing the AND operation, so what is the result? The result is the 0 0. Result is 0. So it will be stored in the register A. So always once we have performed the operation, the result automatically will be stored in the accumulator A register. Similarly, we are performing the OR operation. So OR operation is this is a AND operation. Next OR operation. So what is OR operation? If any one of the input is logic 1, then the output will be logic 1. So if you perform a OR operation between the 0 0, so finally you will get 0. Next 1 1 1. Because the remaining three cases having one of the input should be 1. So that's why the output will be 1 1 1. Similarly XOR. So in XOR gate, if the inputs are having different if the gate having different inputs, then the output will be logic 1. So that means so the second and the third input combinations are different because 0 1 1 0. So for those cases the output will be logic 1, and for remaining cases that means when the inputs are having the same value, then the output will be 0 0. So these are the different operations and OR XOR and complement. So complement means inverse operation. So suppose if you have a register A, so the register having some value like some 48. So this 48 how we can write in a BCD form? So 0 1 0 0 and 8 1 0 0. So this is a data present in the register A. So once we have performed a complement operation, then the contents will be replaced with its complemented form. So that means complement means 0 becomes 1 and 1 becomes 0. So it will become 1 1 1 0 1 1 0 1. Okay. So in this way, the complemented value will be stored in the register. Okay. So these are the different logical instructions. And coming to the shift instructions. So these shift instructions are used when the data is stored in registers. So this type of shift instructions are used when the data is stored in the registers. And these instructions are used for the serial transmission of the data. So in order to transmit the data serially, we are using this serial shift instructions. And the data present inside the register, we can shift either left side or right side. Okay, so either way we can shift the data. Okay, and these shift instructions are combined with arithmetic and logic instructions and data processing operations. Okay, so these shift instructions are classified into three types: logical shift, arithmetic shift, and circular shift. So these are the three main classification. So in the logical shift, again, logical shift left instruction and logical shift right instruction. So that means we can perform shift left operation and shift right operation also. Similarly, in arithmetic shift instruction, so we are performing arithmetic shift left instruction, arithmetic shift right instructions. Similarly, the third case is a circular shift instructions. So circular here also two types are there: circular shift left instruction, circular shift right instruction. Okay. So first one is a logical shift instruction. So these logical shift instructions we can use on the data present in the register. Okay. So here we can perform two types of operations. One is a logical shift left and another one is a logical shift right. So we will see what is logical shift left. That means the data present in a register, we are shifting towards left. Okay, that means suppose see here this diagram. So we have a register and the register is having 1 0 1 1 0 0 1 1. So this is the content of the register. So we are going to perform the logical shift left. So that means the contents, the bits of the register will be moved left side by single position. Okay. So that means here, if you represent, this is a D0, D1, D2, D3, D4, D5, D6, D7. So this is a 8-bit register. So when we are performing logical shift left, the D6 data will be moved to its will be shifted to the here. That means D7 position. So D6 position will be moved to D7. D5 will be moved to D6. Okay. So D0 position will be moved to D1. D1 data will be moved to the position of D2. D2 to D3. So like that, the data will be moved left side by a single position. Okay. So that means D6 bit data will be copied to D7. So that means 0 is copied to the D7. Similarly, the D5 bit data will be copied to the D6 place. Okay, so 1 is copied here. So in this way, all the bits of the register will be shifted to the left side by one position. Okay, so when we perform a shift left, here the D0 position will be vacant because this one will be moved to the D1 position. So the D0 place will be vacant. So that vacant position we are filling with the zeros. Okay. So after performing shift left operation, logical shift left operation, so the contents will be here. This is a so 0 1 1 0 0 1 1 0. So this is a content. So in this way we are performing the logical shift left. Similarly, we can also perform the logical shift right. So that means instead of shifting the data to the left, we are shifting the data to the right side. Okay. So right side means in this way we are shifting the data. So this one. So this one we copy to here, and 0 will be copied to here, and 1 here, 1 here, 0, 0, 1. Okay. So here in this D7. So D7 place is vacant. It is vacant. So this vacant position we can fill with 0. So this is a logical shift left and shift right instructions. And coming to the arithmetic shift instructions. So this arithmetic shift instructions we are performing on signed numbers. So logical shift instructions we can use for the unsigned numbers. So these arithmetic shift instructions we are using for unsigned signed numbers. Okay. So arithmetic, first one is arithmetic shift left. So this arithmetic shift left operation, it is similar to the logical shift left operation. So there is no difference. So it is similar. It is similar to the logical shift left. And coming to the another one, arithmetic shift right. So this arithmetic shift right, it preserves the sign. It preserves the sign. So that means here it is a D0, it is a D7. So for the signed numbers, the MSB position always it represents the sign of the number. Okay. So that means here if the register is having 1 0 1 1 0 0 1 1. So if the register contains this data after performing shift arithmetic shift right, so that means this MSB bit sign will be preserved. So that means the MSB bit will be copied same as it is. The MSB bit will be copied as it is. So that means what is the MSB bit? 1. So 1 will be copied. After that, this MSB bit will be copied to the D6 place. So that means this 1 will be copied to here. 1. Next. So D6 bit data will be copied to the D5. So this is a D5. Copy to here. 0, 1, 1, 0, 0, 1. Okay. So after performing the arithmetic shift right, then the contents of the register will be 1, 1, 0, 1, 1, 0, 0, 1. Okay. So these are the arithmetic shift operation instructions. And coming to the third type of shift instructions, that are circular shift instructions. So this circular shift instructions are again two types: circular shift left and circular shift right. Okay. So that means here in the circular shift instructions, we will not lose any data inside the register. That means whatever the data present in the register, that will be shifted in a circular fashion. Okay. So suppose if you see, this is a register. So it contains 0, 0, 0, 1, 0, 1, 0, 0. So that is a register it contains. So if you perform a circular shift left operation by one position, then see here. So that means this 0 will be copied to here. So 0. So this 0 will be copied to here. 0. Here 1 is there. This 1 will be copied to here. So like that. 0, 0, 1, 0. Okay. So here that means here this MSB bit will be pushed out of the register. Then it will be given to the here. So this 0 will comes to here. Okay. So that is a circular shift left. Okay. Similarly, the circular shift right. Shift right means we are moving the data towards the right side. Suppose if you have a register, so this is a register, 8-bit register. So it is having some data. So 1 0 0 1 0 1 1 0. So if you perform a shift right operation, shift right. So shift right. So that means we are moving the data in this way. Okay, shift right. So we are moving in this way. Shift right, circular shift right. Okay, so that means this 0 will comes to here. So this 1. So this 1. Next 0 0 1 0 1 1. So this 0 will be comes to here. So what is the data before performing the circular shift right? So that is 1 0 0 1 0 1 1 0. So after performing the circular shift right, the contents will be 0 1 0 0 1 0 1 1. So there is a difference before and after performing the shift operation. So these are the circular shift instructions. So in circular shift instructions, we will not lose any data. Okay. Okay. So next one, the third type of instructions are the program control instructions. Program control instructions. So the program control instructions are machine code that are used by machine or assembly language by user to command the processor act accordingly. That means by using this program control instructions, we can control the program execution. Okay. So these are classified into different types. In that, the first one is compare instruction. So the compare instruction is nothing but we are comparing the two values or two operand. So the syntax of this compare instruction is CMP compare R1 comma R2. So that means we are comparing the contents of R2 register with R1 register. So we are comparing the contents of R2 register with the R1. So that is called comparison. So this comparison is very similar to the subtraction. But here in the comparison instruction, we will not store the results anywhere. So that means only we are performing the comparison operation. Then it will updates the flags. It will updates the flags. So only it will update the flags. Okay. So if you look into the subtraction, SUB R1 comma R2. So this is subtraction operation. So that means the contents of R2 register we are subtracting from the R1. Once we have performed the subtraction, the result will be stored in the R1 register. But here, when you are performing comparison instruction, compare operation, it will compare the values. It will compare the data present in the registers. But it will not store the result. Just it will update the flags. So we have different flags like sign flag, zero flag, parity, carry, auxiliary carry. So like that we have different flags. So whenever this comparison instruction is executed, only it will update the flag register, flag bits. The result will not store anywhere. So that is a compare instruction. Second one is a unconditional branch instruction, unconditional branch instruction. So as the name it indicates, unconditional. Unconditional means okay. Unconditional. That means without checking any condition. Without checking any condition, the program control will be transferred. So if you consider a example, jump L2, jump L2. So what is this L2? L2 is the name of the address. The name of the address. So that means the program control will be transferred to the address specified by the L2. Okay. That means here we are not checking any condition. Whenever this jump instruction is there, automatically the program control will be transferred to the address specified in the this address field. So this L2 is address field. So here in this address field, we can mention direct address or the name of the address. Okay. So whenever this jump instruction is executed, then the program control will be directly transferred to the this address. Okay. So here we are not checking any condition. So that's why these are called unconditional branch instructions. Branching. Branching means we are transferring to a new location. Okay. And coming to the third one, conditional. So conditional. So conditional means we are checking the condition. If the condition is satisfied, then the program control will be transferred to the a new address which is specified in the address field of the instruction. Suppose if you consider a instruction BE R1 comma R2. So BE. So that means jump if below or equal. So BE. What is the meaning of BE? BE means jump if below or equal. So R1 comma R2. That means if the contents of the R1 register is below the R2 or equal to the R2, then the condition will satisfy. Then the program control will be transferred to the address specified by the L1. So only the program control will be transferred to the L1 address if the condition is satisfied. If the condition is not satisfied, then the next instruction, the instruction which is available in the next memory location, that will be executed instead of going to a new address. Okay. So these are the conditional branch. So conditional branch means the program control will be transferred only if the condition is satisfied. And the next one is a subroutine. Subroutine. So subroutine is a program fragment that lives in user space. So subroutine is it is a small program which is written in the memory. So that means sometimes we will call a small program repeatedly. So that repeatedly required programs are stored in the memory, and we are calling from the main program whenever we require. So by writing the subroutine program, then we can reduce the execution time, and also we can reduce the memory size also. So that is a benefit of using the subroutine. Okay. So it is invoked by another user program. It is invoked by another user program and returns control to the calling program when finished. Okay. So in order to access these subroutines, we are using the instructions call and return. Call and return. So call and return. That means we have a main program. We have a main program. So in main program, suppose if you have a factorial. So we have a subroutine factorial. So here in this main program, we have a call. Some address will be there. some address will be there. So whenever this call is executed, then the program control will be transferred to the address specified in this address field. So it will go to the sub program. So the program is for factorial finding. So it is having a set of instructions. So in the subroutine program, the last instruction is the RET. RET. So RET means return. RET means return. So that means whenever this return instruction is executed, then the program control will be returned from the subroutine program to the main program where it left from the main program. So it will be returned. It will be returned back to the main program after completion of the subroutine program. Okay. After returning back to the main program, then it resumes its next instructions. It will execute the remaining instructions. So in this way, the subroutines will be executed. Okay. So for this purpose, we are using this call and return. So call and return instructions. And next one is halting instructions. Halting. Okay. So we have two types of halting instructions. Okay. In that, the first instruction is a NOP. NOP instructions. NOP means no operation. So that means whenever the microprocessor executes this NOP instruction, it will not do any operation. Simply it will be in the ideal state. Simply it will be in the ideal state. And we can bring the microprocessor out of this ideal state by giving some interrupt. Okay, so by giving some interrupt signal, then it will come out of the ideal state. And this instruction, it stops the processor. Okay, it stops the execution of the processor. And once it is executed, the processor goes into the halt mode. Okay, and it doesn't affect the contents of the registers and flags. So once the processor will be entered into the halt mode, then it doesn't affect its the register contents and the also flags. So once the processor is halted, it can be brought to the normal mode by resetting the processor. So once the processor entered into the ideal mode, then we can bring it back to the normal state by resetting the processor or by giving some external interrupt. So either way, we can bring the microprocessor back to its normal state. Okay. So halt is the last instruction in any assembly language program. So whenever the halt instruction is executed, then the CPU will stop executing the program. So this is about the NOP instruction. NOP means no operation. Okay. Next, interrupt instructions. So interrupt means something which breaks the continuity. That is called interrupt. So the microprocessor is having different types of interrupts. So like reset, trap, INTR. Reset, trap, INTR. So reset. So it resets the microprocessor. So this may include any or all setting registers to an initial value. So whenever we have reset the processor, then all the registers which are available inside the microprocessor will be set to its initial value. Okay. And the next one is a trap. So trap is having a highest priority, and it is uses a vector address. That means this trap is an interrupt. In order to execute this trap instruction, its corresponding ISR program has to be executed. Okay. So for this ISR, we have the ISR program corresponding to the trap, it is having some address, something some 0020 like that. So when by going the microprocessor into this location, here in this location we have a ISR program. By executing this interrupt service routine program, then this trap will be serviced. Okay, so this trap is the highest priority. That means whenever this traps interrupt occur to the microprocessor, then the microprocessor has to be execute this has to be service this interrupt immediately. So we cannot delay. The processor cannot be delayed. This type of interrupts, and it is a edge and level triggered interrupter. Edge and level triggered. So edge means so here the clock will be represented like this. So this is a rising edge. This is a falling edge. Okay. So that means here the change will occur. Rising edge, falling edge. And level triggered. Level triggered means this one, this area. So that means the processor state can change from this point to the this point. So this is called level triggered. So this is a edge triggered. And the last two interrupt is the INTR. So it is a level triggered and maskable interrupter. So maskable means whenever this interrupt signal occur to the microprocessor, then the microprocessor can delay for some time. But the trap is not like that. So whenever the trap interrupt is occurred, then the microprocessor has to service that immediately. So these are the different interrupt instructions. Next, coming to the another content, that is the instruction formats. Instruction format. So an instruction format or instruction code is a group of bits used to perform a particular operation on the data stored in computer. Okay, and the processor, it has to fetch the instructions, and then it has to decode the instruction, and finally it will be executed. Okay, so that means every instruction, it has to undergo these three phases: fetch, decode, execute. So that means in general the instructions will be stored in the memory. From the memory, the instructions will be fetched. Fetching means retrieving the instruction from the memory. So that is called fetching. Okay. So after fetching, we have to decode. So suppose if you have a add instruction. So once we have retrieved that instruction, then the processor has to decode that. That means it has to determine what type of operation it has to do. So that is a decoding. And also decoding means it converts the assembly language instruction into the machine understandable code. So that is a decoding. Once it is decoded, then the processor has to be execute that particular instruction. Okay. So different computers may have their own instruction set. So different microprocessors having different instruction sets. And instruction code is divided into two parts. So if you consider a instruction, the instruction, it consists of mainly two fields. The first field is the operational code. Shortly we can call opcode. So this opcode, it determines what type of operation it has to perform. And the another field is the address field. Address field, or we can also call the operand. Operand is nothing but on which we are performing the operation. That is called operand. Okay. So this is here you can see the instruction format. So mainly it consists of two fields: opcode, operand, or address of the operand. Address of the operand. And this first field is a indirect bit. Okay. So this total the size of the instruction format is 16 bits. So 0 to 15. So 15th bit is the that is a indirect bit. So I means indirect. So this bit will specifies whether it is using direct addressing mode or indirect addressing mode. If I is equal to 0, that indicates that it is the instruction is using direct address, and if I is equal to 1, then the instruction is having the indirect address. Okay. So direct address means so the address of the operand is given directly in the instruction. So simply directly the CPU has to go to the memory address which is specified in this instruction format, then it can access the operand directly. When I is equal to 1, then it is for indirect address. Indirect address. That means the address of the operand is not given directly in the instruction format. We need to calculate. We need to calculate the effective address of the memory. So effective address means the address of the operand. The address of the operand. So that is a indirect address. So 0 to 11 bits, it specifies the address field, and 12 to 14. So 12 to 14 means 12, 13, 14. So these 3 bits will specify the opcode. Okay. So this is about the instruction format. So based on these operands, so the instruction formats are classified into different types, that are 0 operand instruction, 1 operand instruction, 2 operand instruction, and 3 operand instructions. So first one is a 0 operand instruction. So this type of instructions are having no operands. So that means it doesn't have any operand, only it having opcode. The examples of this 0 operand instructions are NOP, no operation, halt, push, pop. So push means keeping the content into the memory, and pop means taking the content from the memory. Okay. So these are also called stack organization, because the push and pop instructions, they are using the stack memory. Okay. So suppose if you have the expression x is equal to a plus b into c plus d. So this we can write by using push a. Push a. That means the content a register content will be pushed into the memory. Then push b. The content of the b register will be pushed into the stack memory. Then we are performing the add operation between the a and b registers. Okay, so now we got this value. Next we want the summation of the c plus d. So we are pushing the c register data into the stack. Then we are pushing the d register data into the stack. Then we are performing add operation between the c and d. Okay. Then we are performing the multiplication operation, because here we need to perform the multiplication. So mul. Okay. Next pop. So after multiplication, that result we are storing in the somewhere in the memory. So that location will be given by TOS. TOS means top of the stack. So the result will be stored in the top of the stack. Then from the top of the stack, we are copying to the some register X. So that means finally the result will be stored in the register X. So this is a 0 operand instruction. And next one is a 1 operand instruction. So this type of instructions are having only 1 operand. So examples: load A, load accumulator, add B, store B. So these are all this type of instructions. They are using only 1 operand. Okay. So it uses the AC register for all data manipulation. So this 1 operand instructions, it will uses the accumulator as the default register. So one address can be register name or memory address. Okay. So in order to evaluate the expression, so first we should load the register A value into the A. Next we should add it. Okay. So load A. So that means the A value will be loaded into the register A. Then add B. That means the contents of A register will be added with the B. Okay. Then that addition operation will be stored in the memory location T, top of the stack. Next, we are loading the C value. Then we are adding the D value with the C. Then the result will be stored in the T location. Finally, we are performing the multiplication between this and this. So finally, you will get the value that we are storing in the some memory location X. So this is a one operand instruction. And coming to the two operand instruction. So the two address registers or two memory locations are specified. So here it uses two operands. This is one operand and this is another operand. So examples are move A comma B and add A comma B. So that means here the contents of the B register we are moving to the register A. Similarly, the contents of B register we are adding with the contents of the A register. That means here two operands we are specifying. Okay. And suppose here, so in order to evaluate this expression, X is equal to A plus B into C plus D. So first we need to add this, perform this addition operation. After that, C plus D addition operation. After that, we need to multiply the, we need to perform the multiplication. So for that purpose, move R1 comma A. So first A value will be loaded into the register R1. Then we are performing the add operation with the B. So add R1 comma B, because in already R1 register we have the contents of the register A. So that the contents of the register A we are adding with the B. Finally, the result will be stored in the C. The result will be stored in the C. So from the C we are copying to the R2. Okay. Okay. So next one, move R2 comma C. So C value we are copying to the R2. D value we are copying. D value we are adding with the register R2. Okay. Okay. So now the A plus B result it will be available in the R1, and the C plus D value it will be available in the R2. So now we are performing the multiplication between this R1 and R2 registers. So multiplication R1 comma R2. That means the contents of R2 register multiplied with the contents of the R1 register. Okay. So finally the result, the multiplication result will be available in R1 register. From the R1 register we are copying to the register X. And three operand instructions. So memory addresses for the two operands and one destination. So here for this type of instructions it requires two source operands and one destination operand. Example, add A comma B comma C. Okay. So that means see here. So the contents of the C will be added with B register, and finally that result will be stored in the register A. Next, mul X comma R1 comma R2. So here the contents of R2 register multiplied with the R1 register. Finally the result will be stored in the register X. Okay. So here this expression can be implemented using this add R1 comma A comma B. So that means so here these are the two operands, source operands, and this is a destination operand. So total three operands we are specifying in the instruction. So for this A plus B, so we are performing the contents of A register with the contents of the B register we are adding with the A register, and finally the result will be stored in the R1 register. Similarly, C plus D, and finally we are performing the multiplication between the R1 and R2 register, because in the R1 register we have the A plus B value, and in the R2 register we have C plus D value. So that's why we are performing the multiplication between R1 and R2 registers. Finally, that result will be copied to the X register. Okay, so in this lecture we have seen different assembly language instructions and their instruction formats. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.